everyone, it's me, Mrs. K, and we're going to be doing another science experiment today. Let me kind of focus us down here a little bit on our pan of water. We're going to be talking about deep water currents versus surface currents. So both deep water and surface currents. So this is a paper we have if you want to follow along with me. All right, so there's two types of currents that I just talked about. I just said them. Deep water currents, which obviously probably occur underneath, down at the bottom, deep, and surface currents on the top, on the surface. All right, so the movement of deep water currents depends on how salty or the salinity of the water is, okay? Its temperature and its density, which means how thick it is, all right? So three things: the salinity, how salty it is, the temperature, and its density, how kind of thick it is, all right? So surface currents are mainly caused by the wind, which is a result of how the earth rotates. So the wind. All right, this is hot water. I don't want to cool it off yet because we needed hot water for our experiment. Okay, so I measured, this activity is going to demonstrate both types of currents. So let's hope it works out. All right, so I measured in my cylinder here, I already did it, 97-ish ml of very cold water, and I went ahead and put a ice cube in there to keep it very cold. All right, so I don't know, I think it could be a little colder. All right, and I added salt to our water, and I already did that so it could mix it up. Now let's look at the difference between this water in my glass container and the water in the cylinder. Now see, not as clear, okay, because it now has density because of the salt that we put in it. It's denser because of the salt. We're comparing it. We notice that it has a density now. It has more density because it's so salty, okay? So now we're going to add, it says blue in there, but I don't have blue. So we're gonna add green food coloring in here. Sometimes water's green, right? Bloop. Let's see, should we add 2 drops? 2 drops. 2 drops of green water, all right? And we're going to set it, we gotta pour it into a glass. Oops, I might have stained my thing. All right, I have a glass here. We're gonna set it aside. Bloop, bloop, bloop. I'll just rinse that out with bleach later if I stained it green, which I did not. Okay, so now we have our green water here. Okay, so we're going to add some salt to our baking dish here of water. So now we're gonna make it have some density too. It says 60 ml of salt. That says it's 4 tablespoons, but in my experience with these experiments, they tell us to add too much salt and I can't get it to dissolve. So we're gonna add 2 tablespoons of salt. And hopefully this will dissolve pretty quickly. All right. We've got 2 liters-ish of very warm water, and add the salt and stir until it's dissolved. All right, so we're just gonna stir this up. Use my other spoon, okay? We're gonna stir it up. And let that dissolve a little bit. And while it is dissolving, we're gonna talk about a few things. And I have very warm water here, so it probably will dissolve pretty quickly. All right, because our waters both had to have the same density of salt. Because remember, we're experimenting with the temperature of the water, not the saltiness of the water, not the salinity like we did the last time. All right, so we now have salty water. All right. There we go. Now, think about how deep water currents form in the ocean. Cold, salty water, so we know where the North Pole is, right? We have our globe, right? We have the North Pole up here. So, cold, salty water near the North Pole is very dense, okay? So the water is, dense up there. It's not as, it's pretty thick, okay? So it's thicker up in the North Pole than it would be near the equator, okay? So it sinks, so that water will sink and flows down toward the equator, all right? Where it's heated up, because we know that's the hottest part of the earth is at the equator, okay? Then that water will rise because now it's less dense and flows back toward the North Pole as cold water moves in. So it's a cycle. It's not our water cycle like, falling from the earth, but now we're on the earth and we've got the cold water up at the North Pole, which is cold, and then it sinks, and then it flows down to the equator where it heats up and then rises and then goes back up to the North Pole and then sinks. So we've got this constant flow of water, okay? So now we're going to add the cold water, it's still pretty cold, to our warm water, and we're going to see what's going to happen. So pause the video and tell your teacher in the chat box, what do you think is going to happen? Will the cold water sink just as it does in the ocean? Okay, we're going to be able to see it because of the color, because I colored it green. All right, so pause the video. Tell your teacher in the chat box what you think. All right, so I'm going to pour the cold water into the warm water slowly into one end of the pan. All right, observe what happens to the cold water, the cold, dense water. All right, I'm gonna move it down here. Oh, look at that. Can you guys see that? The cold, dense water. It's creating deep surface currents, or deep water currents, not deep surface, deep water currents. That was so cool. Did you guys see that? Whoa, that was really cool. All right. We saw the cold salt water sink and move across the bottom of the pan, creating a current. Did you guys see all those currents in there? You should rewind the video and watch that again. Rewind the video and watch that again. I don't know how to do slow-mo, but now it's starting to get all, it's still down there near the bottom, because that is like really cool, guys. Look at that. It's still down near the bottom. That was pretty awesome. All right, now I'm going to gently blow through a straw across the surface of the water, and you can see the ripples across the top. All right, those are very good ripples, are they? All right, so that's the difference between deep water currents and surface currents. Pretty cool. I hope you guys enjoyed this video. I enjoyed making it.